Welcome to lesson 1-1 on linear equations. So linear equations, hopefully those are two words that we recognize. Let's first talk about equations. When we say equation, we mean anything with an equal sign in it. So for example, 3x plus 2 equals 7, that's an equation. 2 times 6 equals 12, that's an equation. 2 times 6 equals 32. That's not true, but it has an equal sign in it, so we still consider it to be an equation. Here, when we are talking about linear equations, what we mean by that is that every variable term is going to be to the first power. So we will not see our variable raised to the second power, no square roots of our variable, and we're not going to see our variable show up in any sort of denominator when we're talking about a linear equation. Now we have three different types of equations. The one that we're going to encounter most frequently is what we call a conditional equation. A conditional equation is one that is true sometimes. There are particular values of our variable that make it a true statement. An inconsistent equation, that's going to be one that is never true. The example that I gave of 2 times 6 equals 32, that is an inconsistent equation. That is never going to be true. And then finally, an identity, that's going to be an equation that is always true. 2 times 6 equals 12. That is always true, so we call that an identity. All right, so let's jump into this. Let's look at a type of problem that we're going to see in this section. So we're given this problem here, solve 2x plus 7 equals 5x plus 4. So notice 2x plus 7 equals 5x plus 4. We see our equal sign here. This is an equation. And notice that our variable x, each term is raised to the first power, so this is in fact a linear equation. Now I hope that these are relatively familiar to us, but if you don't recall how to solve this, remember the idea is we want to get the x completely by itself. So what we need to do is we need to choose one side of our equation to put our variable terms on, and we're going to put our constant terms on the other side. Now it doesn't matter which side you choose, but once you choose one, you have to stick to it. Let's put our variable terms on the right-hand side of our equation. So I'm going to go ahead and just recopy the equation real quick. So 2x plus 7 equals 5x plus 4. So we said we want to take all of our variable terms to the right-hand side. So I'm going to subtract the variable term on the left-hand side from both sides of the equation. So I'm going to subtract 2x from both sides. So on the left-hand side, my 2x's cancel out, so I am left with just my 7. On the right-hand side, 5x minus 2x, that is 3x. My 4 stays there. Now I want to get the x completely by itself. Notice I still have this constant term on the right-hand side of the equation. So I'm going to subtract that term from both sides. Notice when I do that, that is going to isolate my variable term on the right-hand side. It is by itself now. I will have no constants. On the left-hand side, 7 minus 4, that is 3. Now I want to get the x completely and totally by itself. So notice here I'm multiplying it by 3. So we're going to divide both sides by 3. So 3x divided by 3, that is x. 3 divided by 3 is 1. So here's my final answer. X equals 1. All right, let's look at another example. Now for this one, let me show you a way that we can shave just a little bit of time off of our work when solving these equations. So here we have a new equation, 7x plus 2 equals 3x minus 9. I'm going to copy the equation real quick. 7x plus 2 equals 3x minus 9. Oh. Now remember, we want to get the x's completely by themselves on one side and the constants on the other. Once again, it doesn't matter what side you put the constants on. I tend to choose the side so that the coefficient of my constant is positive, but you don't have to do that. So in this case, I'm going to subtract the smaller term. So here I'm going to subtract 3x from both sides. So when I do this, that's going to put all of my variable terms on the left-hand side of the equation. That means I want to put all my constant terms on the right-hand side. So the constant term on the left-hand side I need to get rid of. So I'm going to also subtract 2 from both sides. Now it's perfectly fine to do these two things simultaneously. In fact, when we're trying to do this quickly, this is probably what you would want to do. So let's go through what we have here. 7x minus 3x, that gives us 4x. 2 minus 2, that cancels out. 3x minus 3x, that cancels out. Now be careful here. If you're going to mess up somewhere, here's where it's going to be. If you don't add these correctly or subtract them correctly, negative 9 minus 2, remember the same sign, so we're actually going to add them. So we have negative 11. So 4x equals negative 11. Once again, I want to get x completely by itself. I'm multiplying by 4, so I will divide by 4 on both sides. So my final answer then is going to be x equals negative 11 over 4. Do not worry about getting somewhat odd fractions for your answer here. In fact, for many of the drill problems that you see on the homework, you are going to get some potentially awkward fractions. That is okay. Well, we unfortunately aren't always going to have perfect numbers in math problems. So don't worry. As long as your technique is correct, you're going to get the right answer.